Hi, it's Kip Bates here. A gorgeous sunny day here in Finland, so the kids are splashing around in the lake, and therefore, what better thing to do than record a video on different data storage structures? And this is sparked by a previous video where I was talking about the difference between a blockchain and a distributed ledger. So let's run through it all from the bottom up to the top. Now, this is off the top of my head, so I'm probably going to make a few mistakes here and there along the way, but never mind. At the very bottom, we have how data is stored in computers, and that's the zeros and ones, and that's done either with a persistent storage such as a hard drive or a flash drive, or with memory. Basically anything that can store ones and zeros. Maybe it's persistent in that it works even when the power's off, maybe it needs to have power, but it's all actually pretty much the same stuff. Then on top of that, you build a file system where you group batches of ones and zeros in a meaningful way, give it a header to identify it as a file, and you have a file index so that you can find those individual files. That's the most basic useful data storage. Then on top of that, we can build a database, and databases are focused on records and particularly being able to search records. So a database can be embodied within a file. You can find a file like database.sqlite, for example, if you're using a SQLite database. But the idea behind a database is that you structure the data in an orderly record-based manner, and you have a way of searching through those records quickly. And in fact, I'd say that the main feature of databases is this search ability, followed by the possibility of updating records. Then move on to ledger. Now, you see, my take on ledgers is that the key thing that makes something a ledger is that it is meant to be effectively immutable. Now, if you look at accounting ledgers, yes, you can change them. If you spot an error, you can sit down with your auditor and your accountant and say, look, we need to correct that. But the idea of a ledger is that there is a record of what happened through time, and that nobody can go in and fiddle the books. Now, of course, in practice, you can fiddle the books. I made the philosophical statement that nothing is immutable, mainly down to the fact that the universe will eventually end. It was a bit of a sort of flippant throwaway remark, but of course, nothing is truly permanent. However, you can have a shot at it to make it better than the lack of permanence or lack of a sort of traceability of changes that a traditional database has. And that, I think, is what distinguishes a ledger from a database. And in the previous post, there's a reference made to the 1991 paper, where what the guys were doing there is basically time-stamping updates or changes to a database in such a way that by having it distributed across a number of parties, you couldn't go in and make a change and then hide the fact that you made it. So kind of a first digital ledger, although of course we've had paper ledgers around for a long time. Then when you bring in, and I've just referenced that, the distributed part, you can have a distributed database where you have multiple copies of the database, and you can have a decentralized database where you have multiple copies and no single one of them is the master. And then you need to have some kind of method whereby you handle conflicts. If two conflicting changes are made at roughly the same time, there needs to be a decision-making process in order to decide which of those two changes is the valid one. And if you bring that over into a ledger, so you now have a distributed, decentralized ledger, then not only are you making sure that there are copies, multiple copies across different parties, you bring this consensus system in order to handle conflicts, and now you're on the way to having a system that allows you to keep accounts where there's no party in control, and that's distributed ledger technology. And then within distributed ledger technology, you have blockchains. And a blockchain is a particular instantiation of a digital ledger technology where data is, transactions are batched into blocks, and the blocks are added at a regular rate, or a statistically regular rate. So there you have this sort of linear hash linked list with the packages in the list containing transactions and basically batching the transactions. And then if you decide that you're going to actually have a permissionless blockchain where anybody can join in and submit transactions and submit potential new blocks to be added to the blockchain, and if you make it open so it's not running on a VPN or some kind of private network, then you have an open public blockchain. And some people consider that to be a blockchain and permissioned blockchains not to be a blockchain. But my take is that if it's got the data structure that a blockchain has, then it's a blockchain, and if it's permissionless and open, then it's a permissionless and open blockchain. But you know, that's open to debate. These things are not set in stone. We can all decide amongst ourselves in any particular group how we're going to use these words. So there you go. That was a rapid tour across how data is stored and what properties that data storage system might have. I hope that gave a little bit more of an insight. Now, we can all have arguments and debates about nitty-gritty ins and outs. You know, is this really a blockchain or is it not? Is this really a distributed ledger or not? But as far as I'm concerned, that's the kind of broad brushstroke way of categorizing these things. But as is always the case with categories, it's a human attempt to put things into boxes that don't necessarily neatly fit into boxes. We do this all over the place, for example, in biological taxonomy or things like that. So anyway, I'll wrap it up now because it's gone on a bit longer than I expected as usual. I'll see you in the next video soon. Bye for now.